Okay, class, today we're going to be studying section 4.2, which is quadratic functions. We will be able to convert between the different forms of quadratic functions. First, we have to think about what a quadratic function is. A quadratic function is any function in which the degree, or the highest power, is a square. There are three ways to express a quadratic function. The first way is transformation form, which is often the form that we use to graph. Notice the h and the k. The h and the k represent the vertex of the parabola. Remember, we always do the opposite of the number with the x. Polynomial form would be the form with no parentheses. And x-intercept form would be factored. Notice that in x-intercept form, there's a coefficient out front, and there are no numbers being multiplied to the x's. So that's kind of a key thing that we'll talk about in the future. So let's do an example. For the function f of x equals negative 4 times x minus 2 squared plus 5, find the vertex, the x-intercepts, the y-intercepts, and graph. So first, I could graph this right now. I know that I have a vertical stretch of negative 4. I know that I'm going to shift forward 2 and up 5. The forward 2 and up 5 give me my vertex. I know the negative 4 is going to stretch it, but I'm going to follow the directions and first find the x-intercept. The x-intercepts occur where the y value is 0, or the function is equal to 0. So I'm going to plug in 0 for f of x, and I'll solve this. Now once again, I could multiply this whole process out, but it might be a bit faster to just isolate the squared portion of the function. Divide by negative 4. Now is the time where I square root. So it's the square root of 5 over the square root of 4, which is 2. So my x-intercepts occur at 2 plus or minus the square root of 5 over 2. It'll be hard for me to plot that point, but that's okay. Now for the y-intercept. The y-intercept occurs wherever x equals 0. So all I have to do is plug in 0 for x. So y equals negative 4 times 0 minus 2 squared plus 5. So 0 minus 2 is negative 2. Square would be 4. Negative 4 times positive 4 is negative 16. Plus 5 is negative 11. And that would be my y-intercept. Alright, so now that I found everything that it asked me to, I'm going to go ahead and graph it. Now I know that I shift forward 2 and up 5, but remember, first we want to focus on our parent function and take care of our stretches. So every y gets multiplied by negative 4, so that means the parabola is going to flip upside down. It's going to become a lot skinnier. And so that parabola will get shifted forward 2 and up 5. And so I know that this graph is pretty symmetrical. It's going to be symmetrical along this line here in the middle. Let me erase my other compound so it's a little bit easier to see. And my x-intercepts are pretty hard to graph, but I can make sure that I plot my y-intercept, which is down here at -11. This graph is quite skinny and increases very, very rapidly. And so there you have it. We have answered all the portions of the question. Convert the equation into transformation form and find the vertex and x and y intercepts. Whenever we want to be in transformation form, we need to use completing the square. So remember, when we complete the square, our leading coefficient needs to be 1, which in this case it is. And we want to add and subtract a number that will make this portion be a perfect square. So you want to think about what three numbers will make this x squared plus 2x plus what give you a perfect square. And remember the trick, it's b over 2 squared. So since my b is 2, I have 2 over 2 squared. Remember, I have to add and subtract the same number because that's the same thing as adding 0. Now, these three numbers I'm going to end up factoring. Factors of 1 that add up to give me 2 would be x plus 1 and x plus 1. So I have x plus 1 squared, and then I combine these two numbers together. -1 plus 3 is positive 2. So this is vertex form. Now I can figure out the vertex opposite of the h, so -1, and then keep the k the same. And to find the x and y intercepts, it's just the same as I did it before. You could use this function down here or this function up here to find either one. I kind of like the function in vertex form because I think it solves a little bit faster. So here are my y-intercepts, or my x-intercepts. Subtract the 3. And try to square root both sides, but if you notice, we're going to end up square rooting a negative number, which means that I have no x-intercepts. That means that the graph is never going to cross the x-axis. So for the y-intercepts, again, you can use any function you want. I like to use the vertex form because I think it solves just a little bit faster. So plug in 0 for x. 0 plus 1 is 1, squared is 1, so 1 plus 2 is 3. So I've answered all the questions. I found the vertex, there are no x-intercepts, and the y-intercepts occur at 3. This is a good place for us to stop for today. If you have any questions, please write them down. We're going to go over them more in class.